This is 99% Invisible. I'm Roman Mars. It's summertime in New York. The year is 1902.
And the Sackett and Wilhelm's printing company in Brooklyn has a problem.
That's producer Emmett Fitzgerald.
They're trying to print the popular humor magazine, Judge.
And it's really hot and there's a lot of humidity, and they're having trouble getting the inks to set properly on the page.
This is writer Stephen Johnson, author of the book How We Got to Now. He says the problem isn't so much the heat, but the moisture in the air, which was warping the paper and throwing the print out of alignment.
And so they hire a young, enterprising engineer by the name of Willis Carrier to solve this problem and basically pull the moisture out of the air inside the printing plant.
And Carrier develops a system that pumps air over cold metal coils.
And it works. It pulls the moisture out of the air, and the magazines are printed more efficiently, and the inks don't run. But it has the side effect of, as it's pulling the moisture out of the air, it also makes the air cooler.
And so, of course,
everybody wants to have lunch in the room with his new machine. Everybody's like, well, this is so nice in here. I'm going to bring my sandwich and sit next to the printing press because the air is so much more pleasant.
Carrier had invented air conditioning. And he began to think that maybe his new technology could do more than just keep paper dry.
Maybe it's something that could actually be harnessed in the service of just human comfort.
He first installs his system in textile factories, tobacco plants, and other industrial workplaces that required low humidity levels. But his invention really catches on in a very different kind of place.
So before air conditioning, the last place you would want to go in the summer was to crowd into a movie theater with 1,000 other human beings on a day when it was 95 degrees out, right? That would just be completely intolerable.
And movie theaters really struggled to sell tickets during the summer months.
So Carrier approaches a bunch of theater owners all around the country with an idea. I'll install a new machine that turns your place of business into a crisp, cool oasis. It won't be cheap, but you'll make up for the cost in summer ticket sales.
And that's exactly what happened. Theater owners advertised their chilled air, and people came out to air-conditioned theaters in droves.
Yes, you lucky people, just sit back for a moment, relax, and notice the delightfully clean, cool, and refreshing atmosphere of this scientifically air-conditioned theater. Great, isn't it?
This advertisement from the 1940s shows a bunch of theater goers wearing fur parkas and icicles dripping from the ceiling.
This theater.
Suddenly, movies went from being the last place you'd want to be on a summer day to being actually one of the nicest places to be. And this whole tradition of having these big movies that come out in the summer became possible.
The summer blockbuster was born.
But air conditioning would do a lot more than just create the summer blockbuster. It would dramatically change where people in the United States lived and the design of our buildings and homes.
But the air conditioning revolution didn't happen all at once.
Before World War II, a few wealthy elites had air conditioning systems installed in their mansions, but mechanically chilled air was still seen as a luxury, something to be enjoyed at the theater, but certainly not in your own home.
But Willis Carrier wanted to change that. In a 1929 speech, he said, "Air conditioning and cooling for summer may become a necessity rather than a luxury, and we will look upon present times as marking the end of that dark age in which there was but relatively little cooling for human comfort."
The big transformation for air conditioning that really arrives after World War II is, like so many stories of technology, really a story about miniaturization, of taking something that was really big and shrinking it down.
Early AC systems were massive, way too big for an individual home. But by the late 1940s, Carrier and other companies were selling air conditioners that could fit in your window. But they were expensive, and it wasn't clear at first that people would buy them.
I think advertising played a huge role in the increased use of air conditioning in the residential sector. And what's really interesting is that the advertising really played on the role of women and their social status.
This is Gail Brager. She is an architecture professor at the UC Berkeley College of Environmental Design and an expert on thermal comfort.
So if you look at the advertising in the 1950s, a lot of them showed women dressed like Beaver Cleaver's mom, with the pearls and the gloved hands and dressed well. And it was really trying to associate social status with air conditioning, that if you have air conditioning, you can live this life of leisure and you wouldn't have to sweat with the toil of housework.
These ads also played on the idea that with air conditioning, homeowners could take control over nature.
The desert, 110 by day, cool enough to need heat the same night.
Here's an air conditioning commercial from the early 1960s that takes place in Palm Springs.
The maximum test for air conditioning. What system works best? Let's ask the owner of this desert showplace, Miss Dinah Shore.
Hi. With my year-round gas air conditioning by Arkla, I just touch the thermostat for delightful cooling or comfortable heat in every room. Humidity controlled, dust and pollen filtered. My indoor climate is always perfect.
It was very compelling, the advertising, and I think that really played on people adopting air conditioning more into the home.
In 1960, 13% of homes in the United States had AC. By 1980, it was up to 55%.
Today, it's close to 90%. In just a few decades, air conditioning went from luxury to necessity, just as Willis Carrier predicted.
The ubiquity of AC has had a serious impact on how, and maybe most profoundly where, we live.
All of a sudden, there are parts of the United States that had historically been really unpleasant to live in, particularly during the summer months, that suddenly, because of these home air conditioning units, are now actually delightful places to live.
The population of states like Arizona and Florida exploded.
So in that period after the introduction of home air conditioning, there is this really arguably one of the largest migrations of people in the history of the United States, moving from the north to the south to what we now call the Sun Belt.
If you could air condition your way through the summer, then living in the middle of a desert or a humid swamp was no big deal.
In just 10 years, Tucson went from 45,000 people to 210,000 people. In the same decade, Houston almost doubled its population. And Florida during, kind of the 1920s had only 1 million people living there.
But 50 years later, there were nearly 7 million people in Florida.
This mass migration was so significant it changed the political map. Increased populations meant states like Florida got more votes in the Electoral College. And since a lot of these new southward migrants were conservative retirees, they tended to vote Republican.
You begin to build this kind of Republican Sunbelt coalition that didn't exist before. And that coalition is really crucial to Reagan's successful bid for the presidency in 1980.
There were obviously a lot of different factors that led to Reagan's election.
But I think that had air conditioning not been invented, Reagan might still have gotten elected, but he would have required a different political coalition to make it possible.
The population of the Sun Belt boomed with the advent of air conditioning. But it's not as if no one lived in these places before AC. And those who did had developed lots of strategies to beat the heat, including forms of vernacular architecture that were carefully attuned to the climate.
Vernacular refers to traditional architecture that develops in a particular place, and it's often driven by local environmental conditions.
So if you look at traditional buildings in hot climates, so many of the elements are going to be different if you're in a hot, dry, or a hot, humid climate.
In the desert Southwest, houses were traditionally built with hefty materials like adobe and stone that can absorb heat.
You're soaking up the heat during the day, keeping it from getting inside, and then releasing it to the colder air at night.
Homes in the Southwest also tended to have flat roofs and small windows that could be closed up during the day and opened at night to let the cool air in.
However, in the humid Southeast, the vernacular architecture tried to maximize shade and air movement. There were screened-in sleeping porches, breezeways between rooms, and cupolas in the roof to draw cool air up through the house.
You tend to have much larger windows, much larger operable windows, so the entire facade could be opened up. You might have much larger shaded porches and balconies, so there's a lot of outdoor living. And so you can look at the architecture and it says something about the place.
On-demand cold air freed architects from the challenge of designing a home that was uniquely suited to the climate around it.
And as we got more mechanical systems and the power to heat and cool buildings through mechanical systems, I think architects started relinquishing control of environmental conditioning to the engineers.
Air conditioning systems were expensive, but home builders made up for the cost by cutting down on passive cooling features. And little by little, the local architectural traditions rooted in the climate gave way to tightly sealed, mass-produced tract homes.
So a house in the Southwest might look the same as a house in New Orleans, which might look the same as a house in Minnesota. And whether you were in a hot, humid, hot, dry, or cold climate, I think architecture really lost a sense of place.
The rise of tract housing had to do with more than just air conditioning. It was influenced by the development of the highway system and the suburbanization of American life. But AC enabled the mass production of affordable homes that could exist in many different climate zones.
Air conditioning didn't just change residential architecture. It revolutionized the design of skyscrapers, schools, and office buildings.
Before air conditioning, the only source of cool air was the outdoors. And so offices usually had high ceilings and lots of windows that people could open.
And so all offices had at least one wall that was exposed to the perimeter. You might have courtyards in the center of buildings so that even the spaces that weren't on the street would have access to the air and light on the inside.
If you look at the floor plans of many mid-rise buildings from the early 20th century, they often have these thin, irregular shapes. They looked like letters when viewed from above.
So we sometimes called them alphabet buildings because they'd be in the shape of E and H and I and O.
But with air conditioning, buildings could fill up the entire lot with offices deep inside the core of the building, nowhere near a window. Air conditioning also changed facade design. Before AC,
they addressed the issue of too much sun by providing appropriate shadings or awnings. Facades were carefully designed to avoid too much sun coming into a space.
This is Lisa Heschong, an architect who spent her career studying light in architecture.
When we discovered air conditioning, all of a sudden we could have these continuous glass facades because we had solved the problem with power conditioning instead of appropriate facade design or building design. It was just brute force power. We'll air condition our way out of all of these design issues.
Now, this wasn't all a bad thing. Many modern architects were happy to cede the problem of thermal comfort to the engineers. It meant they could focus on aesthetics.
And so it was incredibly empowering to architects to be able to relinquish that control.
With AC, they were free to design the sleek, hermetically sealed glass towers that became hallmarks of modernism. It's safe to say that without air conditioning, we would not have many of the great modernist buildings of the 20th century.
Oh, absolutely not.
But as a consequence, the modern-built environment in the United States is now totally dependent on air conditioning. A lot of our buildings would be uninhabitable in the summer without AC.
And all that cool air requires a lot of power.
We now use as much electricity for air conditioning as we used for all purposes in 1955.
This is Stan Cox, author of the book Losing Our Cool. He says AC consumption has continued to rise. From 1993 to 2005, the amount of electricity used for air conditioning doubled nationwide.
One of the big reasons was that houses were getting larger, and virtually all of those newly constructed ones were getting central air installed in them.
The larger the home, the more space needs to be filled with cool air.
It's crazy to think about it to me that on a hot day here in Kansas, there are 3,000 square foot houses being kept at 70 degrees all day long, and all the occupants are off at work and school, and so it's not cooling a human being at all.
And all that air conditioning might be keeping our buildings cool, but it's making the outside world hotter.
The additional greenhouse emissions from air conditioning in the United States add up to about 500 million tons of CO2 equivalent per year.
He says that's more than the entire construction industry, including the production of materials like concrete.
So it's a very significant amount.
In fact, in 2010, when Stan Cox wrote his book, he says the U.S. was using as much energy for air conditioning as the entire continent of Africa was using for all purposes.
And all of these structures that require massive amounts of energy to keep cool, we've been exporting them to the rest of the world, including really hot places like Dubai.
What America has been fantastic with across the board in terms of design and architecture is making a brand and exporting it. However, a lot of that architecture is non-responsive to the conditions of the Middle East.
This is Manit Rastogi, an Indian architect and co-founder of the firm Morphogenesis, based in New Delhi. Rastogi says that a lot of the buildings in Indian cities today look like they could be buildings in any other city around the world. Sealed up glass towers that require a lot of air conditioning. But India also has a long history of vernacular architecture designed to keep people cool. And Rastogi started looking back at some of these old buildings and thought,
wait a minute, we used to do this really well, not so long back. Why are we building differently today?
Rastogi has devoted his career to designing functional modern buildings that borrow passive cooling techniques from traditional Indian architecture and require very little, if any, air conditioning, like his design for the Pearl Academy of Fashion.
So the Pearl Academy of Fashion is on the outskirts of Jaipur, which is essentially a desert climate.
When Rastogi started working on the Pearl Academy, he looked at old Indian buildings in hot, dry climates for inspiration. He studied old forts and palaces to see how they stayed cool. And he was particularly impressed by a feature called the Bauli.
Bauli, yes, the Bauli, the stepwell.
Baulis are traditional Indian stepwells found in many old palaces. They're basically pools of water dug deep into the ground beneath the building and surrounded on all sides by descending steps, intricately carved from stone. The cool temperatures from underground combine with the evaporative cooling of the water to lower the temperature in the palace.
Rastogi decided to put a modern take on this ancient architectural feature in his building.
So we created a Bauli, a stepwell, across the entire site. We dug 3 meters down into the ground and we recycled all the water into that stepwell condition and allowed for evaporative cooling to come up and cool the site down.
The top of the building is insulated using earthenware pots.
And the sides of the building, we put locally manufactured jalis that keep the sun out but let the light in.
The jali is a traditional Indian architectural feature. It's basically a lattice screen filled with all these tiny holes that let in diffuse sunlight without too much heat.
And we put all that together. And when the project finished, we were getting temperatures of 29 degrees when the outside temperature was 46 degrees without air conditioning.
In Fahrenheit, that's 84 degrees inside the building when it was 115 degrees outside. It's still hot, but doable.
For an office building, that doesn't actually sound all that doable. To me, that sounds way too hot.
Yeah, I kind of think so too. But Rastogi says that for someone used to living in Jaipur, India, it's a pretty pleasant temperature. He says thermal comfort is relative.
Standards for what constitutes thermal comfort is where I think the whole problem sort of sits.
Architects and engineers around the world use thermal comfort standards set by the American Society of Heating, Refrigerating, and Air Conditioning Engineers. Historically, these standards have dictated a relatively narrow temperature window that all buildings should be kept at. The only way to be certain that a building can meet that standard all year long is with lots of air conditioning and heating.
But if you've ever worked in an office, you know that some people are always hot, Sharif, while others, Katie, are always cold.
You will never achieve a static environment where 100% of the people are happy.
This is architect Lisa Heschong again.
There's a huge amount of individual variation in what people experience and what they prefer.
Our thermal preferences vary based on age and sex and the climate that we're used to.
But the whole goal of conditioning buildings is to create a static indoor climate, one temperature that will hopefully be the least unpleasant to the most number of people. Gail Brager calls this thermal monotony. She and her team at UC Berkeley have developed new thermal comfort standards that allow for a wider range of temperatures within buildings. Brager doesn't want to get rid of air conditioning altogether, but she thinks we can be more intentional about when and where we use it.
Our environmental conditioning systems think about heating and cooling spaces rather than heating and cooling people.
Brager says we don't need to heat and cool corridors to the same degree as the parts of an office where people spend most of their day.
And she says we can save enormous amounts of energy by letting the temperatures in buildings fluctuate over a wider range and giving people more tools to heat and cool themselves.
To do that, it's going to take a combination of high and low-tech approaches. A window that you can open right by your desk is a great personal cooling device. A sweater is a pretty good personal heating device. But Brager and her team are also developing low-energy desk fans, foot warmers.
And the chair I'm sitting in right now, you might see these dials. This is a heated and cooled chair. And this, to me, is the ultimate form of a personal comfort system, we call it, PCS, because we're all going to feel something different. And we could be sitting in the same environment, but one person may be feeling warm, one person may be feeling cool. And would you like to sit in this chair?
Yeah.
Okay, we're going to switch places.
Okay, let's switch places.
Go ahead. Sit in that chair. You're going to sit in it for a while, and it's going to feel really warm. People are getting more and more used to heated seats in our cars. So why not have heated and cooled seats in our office? And I'm going to reach over and turn it to cooling.
Okay.
And you should feel that pretty quickly.
Oh, wow.
Yeah.
Wow.
It's blowing air across your back and your seat.
Oh, it's so
and you
nice.
You can change it. I have sometimes had, when my back aches, I'll have a heated back.
Reducing our reliance on air conditioning is often framed as a loss, giving up comfort. But neither Gail Brager nor Lisa Heschong see it that way. Back in the 70s, Heschong wrote this beautiful little book called Thermal Delight in Architecture. And in it, she argues that we should think about our perception of temperature as a sense. Just like any other sense, temperature can cause us discomfort, but it can also give us a lot of pleasure or delight. The feeling of a warm fire in the winter, or a cool breeze on a hot summer night, or sliding back into your heated chair after a trip outside. She wrote about
how thermal experience could enrich architectural design, add a new dimension.
And it requires change. It turns out that physiologically, the only way we can have that moment is to actually have some kind of variability in our lives.
Gail Brager has done studies on thermal comfort in buildings around the world, and she's found that people actually prefer naturally ventilated buildings where they can open windows and feel a little bit of control over their own temperature.
Turns out that not only do you tolerate, but you actually prefer a wider set of conditions.
Today, the average person spends about 90% of their time indoors. And Gail Brager doesn't think we should live so much of our lives in thermal monotony.
Imagine life if we ate the same foods every day, right? If we didn't have changing weather and everything was the same all of the time. It would be terrible. But that's essentially what we're trying to do in our buildings.
Towards the end of my conversation with Gail, I reluctantly offered to give her chair back. Should we switch seats? Sure. Get you back in your...
Get me back in
I don't want to deprive you of thermal delight for the rest of this interview.
It's quite nice, isn't it?
It really is. I was not expecting that to be as enjoyable.
I like my chair quite a bit.
You should.
Special thanks to architects Ron Hawsey and Steve Bedanes, who also spoke to us for this piece. Since a bunch of you have asked, Kurt and I are going to talk about terrifying incoming missile false alarms in Hawaii right after this. So a few months ago, thanks in part to increased tensions with North Korea, the Hawaii Emergency Management Agency started doing ballistic missile attack drills. But the other day, someone was initiating a test alert and apparently chose the wrong option from a list of very confusing options. So Kurt is here to give us the details.
So at 8:07 in the morning, a message went out to cell phones in Hawaii. Ballistic missile threat inbound to Hawaii. Seek immediate shelter. This is not a drill. Within a few minutes, officials knew it was a false alarm and started doing damage control. But an actual stand-down alert wasn't issued until 8:45, more than half an hour after it all began.
Okay, so some officials and news outlets are calling for the person who set off the alarm to be fired, while Late Show host Stephen Colbert joked around about the opposite idea.
The agency in question also announced that the employee in question was reassigned. No! You'll keep him in that job. He's the one person on the planet who will never, ever make that mistake again. He knows.
Design guru Don Norman, who we talked with about bad door design, also thinks the focus is too much on the person. His basic argument is that if it's that easy to screw up, there's a design problem to be fixed. And I think it's safe to say that we here at 99PI are members of the Church of Don Norman.
Amen. And really, there are a number of design issues here. It was really easy to make this mistake and to send out the alert. It was also too hard to retract it or issue a correction. And then there's this lack of detail in the message, like where to find shelter or, phone numbers or links to websites that might help people get updates or more information.
So people panicked, and many, fearing the worst, called loved ones to say goodbye, which is just tragic. I mean, this is a very high-stakes design problem.
A lot of solutions are being floated. Some have called for introducing more friction to the process to slow things down and help avoid accidents. And that could involve adding steps, eliminating lists of nearly identical options like they have right now, in favor of more clearly differentiated buttons with, different button sizes and colors, all with the goal of making the test initiation easier and more obvious than sending an actual alert.
So already they're fixing some of these issues, like creating a path to send out a correction more quickly. And from here on out, a second step person also needs to confirm a given selection. But some of these hasty solutions, I think, just focus too much on human error or retracting the alerts like after the fact and not really taking the design problem on head on.
It's totally true. The process really has to be redesigned from start to finish. And some of these changes are in the works, like having longer messages that also have emergency links and numbers. Even then, though, they need to actually test the system more often so that people are familiar with it and know how to react. During this accidental alert, it was discovered, too, that a number of emergency sirens played the wrong tune or just failed entirely.
So it failed both as a false alarm and as an actual alarm. That's very upsetting.
Yeah, it was reported that only 7% failed to signal what ended up being a false alarm, but that still seems just unnecessarily high.
Yeah, but I think we can all agree that we need to lay off the poor sucker who pushed the wrong button.
Oh, definitely. That guy is, I just hope his name never comes out.
Oh, me too. Me too. All right. Thank you, Kurt.
Thanks.
If you want to geek out even more about alarm design, be sure to check out the Mini Stories 4 episode from last week. It's a fun one. 99% Invisible was produced this week by Emmett Fitzgerald. Mix and tech production by Sharif Youssef. Music by Sean Real. Katie Mingle is the senior producer. Kurt Kolstedt is the digital director. The rest of the team includes senior editor Delaney Hall, Avery Trufelman, Taryn Mazza, and me, Roman Mars. We are a project of 91.7 KALW in San Francisco and produced on Radio Row in beautiful downtown Oakland, California. 99% Invisible is a member of Radiotopia from PRX, an independent collective of the most innovative shows in all of podcasting. Find them all at radiotopia.fm. We are supported by the Knight Foundation and listener donors who pitch in whatever they can to keep us making the best audio in the world. You can find the show and join discussions about the show on Facebook. You can tweet at me at Roman Mars and the show at 99pi.org. We're on Instagram, Tumblr, and Reddit too. But if you think, I need more 99pi in my life, we have all the old episodes available and new articles about design every couple of days on our beautiful website. It's 99pi.org. Radiotopia.